Right now, as you listen to these words, something is appearing on the surface of the sun that we have not seen in over a decade. A giant wound, a swirling darkness so large that it could swallow 10 Earths and still have room. It appeared just a few hours ago, as if the sun were slowly revealing a secret it did not want to hide. As soon as it appeared, alarms went off. NASA was watching, NOAA was watching. Every space weather observatory in the world had its instruments locked onto this area because if anything went wrong, we could see something the world was not prepared for. Its official name is AR 4294-4296, a region so vast that agencies had to divide it into 3 separate regions to keep it secret. It is 5 times taller than Earth, 5 times wider than Earth, and it is staring us straight in the eye. Amateur observers say they can see it with the naked eye through a solar filter, an extremely rare occurrence. And here's the question no one dares ask out loud. What if it erupts? What if the largest sunspot in a decade decides to unleash its energy just as Earth is in its path? By the end, you'll understand why scientists are up all night for the next 72 hours, and what the worst is really going to be like. Some of what we're about to tell you may sound like science fiction, but unfortunately, it's all true. The sun is anything but benign. It is a giant fusion reactor, a swirling sea of plasma where magnetic fields constantly twist and break. Sunspots are the scars of that chaos. Dark because at just 3,500 degrees Celsius, they are still hot enough to vaporize everything humans have ever created. The sunspot group that appeared on December 1st, AR 4294-4296, is exceptionally massive. It is so large that it takes 2 days to complete one orbit around the edge of the sun. What worries scientists is the configuration of its magnetic field. The most dangerous form is when opposite magnetic poles are compressed into a single region, like a spring stretched to its limit. Their appearance coincided with a stronger than expected solar cycle 25 event. Instead of a week maximum, solar activity has outpaced all models, with multiple X-flares occurring in quick succession. August 2024 saw the highest number of sunspots since 2001. On November 11th, AR 4274 produced an X 5.16 flare accompanied by a rare G4CME. And now the largest sunspot of the decade is heading directly towards Earth. On the same day, AR 4294 appeared. Region AR 4299 experienced an X 1.9 burst, powerful enough to cause an R3 radio blackout across Australia just 8 minutes later. A high-velocity CME was also recorded, which fortunately did not reach Earth. But as the sun rotates, AR 4294 is getting closer to its most dangerous position. NOAA forecasts a 70% chance of an M-class flare from December 1st to 5th, with the possibility of additional X-class flares. On December 3rd and 4th, there could be a G1 to G2 geomagnetic storm, or even a KP7 enough to bring auroras down to Chicago and Melbourne. The biggest concern isn't the little blips, but the potential of AR 4294. The delta structure suggests a huge reservoir of trapped magnetic energy. If a sudden magnetic reconnection were to occur, the energy released could be equivalent to billions of nuclear bombs. X-rays are just a flash. The real threat is a CME, a billion-ton mass of plasma that could compress or temporarily puncture Earth's magnetosphere, easily knocking out power grids, satellites, GPS, and the internet. The coming days will determine whether AR 4294 is just a spectacular sight or the genesis of the biggest event of the decade. December begins with a stark solar warning. In a world so reliant on technology, the stakes are much higher than they were in 1859. And the sun, as usual, didn't care. At 2:27 UTC on December 1st, 2025, the sun erupted. Just over 8 minutes later, a burst of electromagnetic radiation streaked toward Earth, cutting off all HF communications in the daytime hemisphere. Australia was plunged into silence. Air and sea communications were disrupted for 30 minutes. A single incident from a star 150 million kilometers away. NOAA rated the event R3, strong but not catastrophic. It's just a reminder that modern technological infrastructure can be overwhelmed in minutes by a small change in the sun. The X-1.9 flare came from a small region of AR-4299, not the monster, AR-4294, which is heading in the opposite direction toward Earth. NASA recorded a sharp white flash, accompanied by a high-speed CME that almost hit us. Had it been slightly off course, it could have reached Earth in less than 2 days at the speed recorded in the Carrington Event. Australia lost signal only because the ionosphere was over-ionized. The incident was over quickly, but that was only the beginning. The real threat has always been a CME, a mass of plasma weighing billions of tons, powerful enough to compress the magnetosphere and short out the global power grid. X-1.9 was just the beginning. Solar Cycle 25 was extremely active, producing the X-5.16 flare on November 11th. And history has recorded X-40 to X-45 monsters hundreds of times more powerful. From December 4th to 7th, AR-4294 entered the geometric danger zone. Any flare or CME would be hurtling toward Earth. The NOAA Forecast Center said there was a 70% chance of an M flare and the risk of an X flare remaining through December 5th. G1 to G2 geomagnetic storms were possible on December 3rd and 4th. AR-4294 is so large, so complex, and has a magnetic delta structure, the type responsible for more than 80% of major flares, that observatories have had to split it into multiple sections to track it. The sunspot appeared just as the sun reached maximum solar activity, earlier and more powerful than expected, making it the most dangerous phase of the cycle. The next 3 days don't guarantee disaster, but the conditions for a major event are converging in a rare way, and no one can predict whether it will be explosive or quiet. Power grids, satellites, GPS, and aviation are all on alert, as just one powerful CME at the right time could have consequences far beyond those of 1859 or 1989. Tree rings and ice cores show that the sun has caused larger events in the past, and will continue to do so. AR-4294 doesn't guarantee disaster, but it does increase the likelihood of disaster more than usual. Now all we can do is watch, wait, and hope the sun doesn't choose this time to speak up. Less than 17.5 hours after the historic 1859 observation, the Carrington CME slammed into Earth at an almost unbelievable speed, many times faster than normal. Telegraph systems in Europe and North America short-circuited. Telegraph paper spontaneously combusted, and auroras lit up as far as the Caribbean and Hawaii. It was the most powerful geomagnetic storm on record, but the damage was minimal because the world was still without electricity. Today, things are different. The grid is the lifeblood of clean water, hospitals, transportation, telecommunications, and supply chains. In the United States alone, a modern Carrington storm could cause between $600 billion and $2.6 trillion in damage. The weak point is the roughly 2,000 ultra-high voltage transformers weighing hundreds of tons, built to order, taking more than a year to produce, and with virtually no backup. If just a few are destroyed, an entire region can be without power for months or even years. Quebec in 1989 is a case in point. A storm one-third the size of Carrington took out their grid in just 92 seconds. By 2025, ESA simulations show that a Carrington-scale storm could swell the atmosphere by 400%, pulling satellites out of orbit, causing communications blackouts, disrupting GPS, and the ability to track space debris in an unprecedented chain of events. We already know how it works: an immediate ionospheric flare followed by a CME that creates a geomagnetic storm. But even with this knowledge, humanity is unprepared. Power grids are weak, transformers are scarce, and warnings are given for only a few hours. Worse yet, Carrington isn't the worst-case scenario. In 2012, Fusa Miyake discovered a spike in carbon-14 in tree rings from 774 to 775 that was 20 times stronger than normal, suggesting that ancient trees and ice around the world bore the marks of a superstorm of energetic particles at least 10 times more powerful than Carrington's, perhaps as much as 80 times. Such Miyake events have occurred multiple times in the Holocene, the most powerful of which, 14,300 years ago, was twice as powerful. If a Miyake event occurred today, radiation would be dangerous at cruising altitudes, satellites could burn out instantly, GPS could be down for days, and power grids could be affected by induced currents far beyond their design limits, a domino effect that would spread faster than any existing response plan. We have seen clues in ancient records like the red cross in the sky in 774, but only now are we understanding that it was a powerful aurora at low latitudes. These events are real. They happen in cycles, and statistically, we are right at the point where a major event could happen again. While understanding is limited, modern civilization is completely dependent on the systems most vulnerable to the sun. The rings of ancient trees suggest that Carrington is not the limit. The sun has produced storms far more powerful than this. We rely on statistical rarity to reassure ourselves, but rare is not safe, and if we are wrong, our electricity-dependent civilization will pay the price. A 2,000-year-old tree ring in Japan recorded events 774 and 994, and is now recording 2025. The future may reveal what traces AR 4294 left behind. For now, all we can do is observe and hope the sun doesn't exceed the threshold our modern systems can handle. But that threshold is slimmer than we think. The sun could very well produce a CME far beyond anything humanity has ever seen, and if it hits the right spot, it could come very quickly. A total coronal mass ejection showed the CME was flying directly at more than 2,000 kilometers per second and could reach Earth in less than 18 hours. Warnings were sent to power grids, airlines, and satellites, but most people thought it was just a normal magnetic storm. Then the CME arrived earlier than expected, its magnetic field oriented completely against us. The magnetosphere was compressed, currents were induced along the power lines, transformers began to overheat, protection systems overloaded, and the lights went out. For the first hour, everyone thought it was just a major power outage. But mobile networks quickly faltered, communications were disrupted, and the extent of the power outage remained unclear. By the second hour, transportation was disrupted, accidents increased, and hospitals had to use backup generators. Some medical equipment was affected by electromagnetic interference, forcing staff to revert to manual methods. By the fourth hour, the extent of the damage was revealed. Entire states were without power. GPS was down, airlines were canceling flights, financial markets were unable to open. In homes, refrigerators stopped working and water was still running, but not for long. By the 12th hour, phones ran out of batteries, rumors spread, and reliable information was all but gone. That night, cities plunged into total darkness for the first time in decades. Inconvenience turned to simmering dread. By hour 24, water pressure plummeted as storage tanks ran dry. Stores ran out of bottled water within hours. By hour 36, gas ran out, trucks were immobilized, GPS signals faded. Supply chains began to collapse, and perishable food products began to spoil en masse. By the 48th hour, the damage was beyond quick repair. Many transformers were completely destroyed, requiring months or years to replace. Power companies prioritized hospitals and critical infrastructure, but generation capacity was severely reduced and transmission lines were damaged. 2 days without electricity is not a disaster, but it opens the door to disaster. If electricity is restored in a week, society will recover. If not, everything will change. Food will run out, water will be scarce, disease will increase, social order will break down. Numerous government and energy industry reports have long warned that the loss of just a few critical transformers could cause a nationwide grid collapse, with restoration times measured in years. But in the first 48 hours, few understood what they were facing. It was only when supplies ran low and support was unavailable that people realized this was more than just a blackout, but the beginning of a larger crisis. It all started with a single event, a fast CME headed straight for Earth. We could see it, we could predict it, but we couldn't stop it. And the extent of the damage was not due to when it happened, but to the choices society made, or failed to make, decades ago. 48 hours is just the beginning. When the power goes out, the most dangerous thing is not the darkness, but the water. The entire water supply system, from pumps, filters, sterilizers, sensors, to distribution systems, runs on electricity. When the power goes out, every drop is a drop that is not replenished. The gravity tank will only last a few hours or days. Then the tap will run dry. And when the water stops flowing, things quickly fall apart. Hospitals can't disinfect or cool equipment, firefighting becomes impossible, sanitation systems become clogged, waste runs rampant, and the risk of disease increases. People can survive without electricity, but they can't last more than 3 to 5 days without water. In desperate times, social order can easily break down. Providing emergency water assistance nationwide is nearly impossible. A city of 1 million people needs 1 million gallons of water a day. Delivering that amount of water when fuel is scarce and transportation is paralyzed is impossible. Natural water sources are often unsafe, and filtering, boiling, and disinfecting water requires knowledge and fuel that will soon be in short supply. After 4 to 5 days without water, the casualties would begin. Models have concluded that a prolonged blackout would cause mass deaths, largely due to the collapse of water and sanitation systems. One EMP Commission report even estimated that as many as 2/3 of the U.S. population could die in a year if a nationwide blackout continued. A controversial figure, but one that shows how fragile the system is. Modern supply chains collapsed in the aftermath. Supermarkets emptied not because of food shortages, but because trucks ran out of fuel, GPS failed, cold storage facilities lost power, and payment systems went down. Refineries, pipelines, and gas stations all require electricity, leaving the fuel that powers the entire logistics operation in short supply. With the water shut off and fuel running out, there was no rescue force to help. The entire country was in crisis. The consequences of a powerful CME could be more than just power outages. It could be the collapse of entire civilizations. In a society completely dependent on electricity and clean water, a prolonged grid failure is more than just a technical disaster. It is the beginning of an existential countdown. In the early days of the blackout, society cooperated. But as water ran low, food ran out, and hope for recovery faded, solidarity quickly turned to despair. When survival was threatened, violence that would be unacceptable in peacetime became reasonable for those left with no other choice. With the police out of reach, courts closed, prisons closed, and the rule of law faltered. Order depended on public and individual morality, and that was not enough for everyone. The crisis immediately spread to the global economy. Financial markets collapsed, international supply chains crippled, the dollar lost value, and the world economy was thrown into chaos. The most vulnerable, urban dwellers, drug users, the elderly, and children will be hit first. A prolonged grid failure will not kill everyone, but it will kill those least able to adapt. Smaller examples like Puerto Rico after Hurricane Maria or Texas in 2021 are just a few. Consensus forecasting models predict that nationwide power outages lasting weeks to months would cause massive casualties, largely due to the loss of water, sanitation, and medical infrastructure. One report estimates the death toll could be in the millions. History shows that civilizations have collapsed in similar ways. The Mayans collapsed because of poor water systems. The Norse disappeared from Greenland because they couldn't adapt. The Bronze Age collapsed when many small elements failed at the same time. The common thread is that complexity is powerful when it thrives, but fragile when it breaks down. Modern civilization, the most complex in history, is completely dependent on electricity and clean water. A large CME could cripple that power source and cause the entire system to rapidly collapse. This is not a prophecy, but a warning. Adapt or endure. The Inuit survived, the Norse did not. Flexibility is survival. The sun does not care about our preparations, but we know the history, we know the risks, and we have choices. We prepare or repeat the mistakes of lost civilizations. Earlier this year, ESA simulated a Carrington-like event during a satellite launch. The results showed just how fragile modern technological systems are. The simulated atmosphere expanded 400%, pulling the satellite out of orbit, cutting off communications, and making it nearly impossible to track space debris. The exercise was not meant to reassure, but to emphasize that humanity is not prepared. But almost no one has ever heard of it. Space weather is complex, hard to communicate, and easily relegated to the category of too rare to care about risks. The public fails to realize that the most dangerous threat to technological civilization may not be war, the economy, or climate, but a solar storm. We know the 1859 Carrington Event happened. We know that in 2012, a powerful coronal mass ejection, CME, was 9 days from Earth. If it had happened a week earlier, it could have caused trillions of dollars in damage and taken years to recover. We also know that the weak point of the power grid is its ultra-high voltage transformers. about 2,000 of them across the United States, weighing hundreds of tons, taking 18 to 24 months to build, and most of them imported. We know that if just 9 of them failed in the right place, it could cause a nationwide blackout. But what we don't talk about is why, despite knowing this risk, we don't stockpile transformers, harden the grid, and build real resilience. Protecting the entire national grid would cost only $10 billion to $30 billion, a fraction of the cost of defense. Yet this investment is not made because it is not seen as urgent. Many agencies have sounded the alarm. NOAA keeps a constant eye on the sun. The Department of Homeland Security has classified space weather as a major risk, and congressional committees have written reports. But public awareness has yet to catch up to the danger. We can see the storm from afar, but we are still ill-equipped to protect ourselves when it approaches. At the individual level, contingency measures are only useful in the short term. A few days of water, food, solar panels, or hand-cranked radios are useful in the event of a local power outage. But if the outage lasts for months, no single household can replace the infrastructure of an entire country on its own. What is important is collective action, pressuring governments and utilities to make serious investments, stockpiling critical equipment, and reinforcing the grid. The technical solutions are there. What is missing is the will. Congressional reports, research papers, and insurance industry analysis all point to one thing. The threat is real, quantified, and entirely mitigatable with timely action. AR 4294 may not pose any danger. It may just cause a few spectacular flares and then fade away. But the sun has experienced Carrington and Miyake events before, and it will again. The power grid is as fragile as ever, and whether we are prepared is entirely in our hands. The sun doesn't consider budgetary priorities or utility calculations. It simply obeys the laws of physics. One day, a large CME will hit Earth. When that happens, everything described here will become a reality. The largest sunspot of the decade is currently heading towards us during the most active phase of solar cycle 25. Forecasters are closely monitoring the sunspot and hope that complex magnetic fluctuations will not cause adverse consequences. Now that you know more about this risk than most people around you, you can choose how to handle that knowledge. The information itself is no longer something you can say you never heard of. We have come a long way, from a sunspot to tree rings that hold the memory of millennia, from the first 48 hours of darkness to the fragility of modern civilization. The sun continues its cycle, both nurturing life and bringing with it storms that can threaten it. Tonight, if the sky is clear, look up. The very thing that gives life may also pose the greatest challenge to our technology. Understanding that is the first step to recovery. Thank you for your time. If this article has made you think more about our place under the sun, please share it so more people are aware of this overlooked danger. And if you want to continue exploring science and the universe, please join us. And if you haven't already, consider joining our community to explore the science and mysteries that will shape our universe in the future.